Hello friends, myself R.D. Mahajan presenting my video on Leibnitz Theorem. Let us solve the problem. If y is equal to sine of m sine inverse of x, then prove that 1 minus x square into yn plus 2 minus in bracket 2n plus 1 into x yn plus 1 minus in bracket n square minus m square multiplied by yn is equals to 0. Once again, if we observe the terms of derivatives of y, first one is yn plus 2, second one is yn plus 1, and third is yn. All the derivatives are in decreasing order, and whenever we find such type of term, it is the problem of Leibniz theorem. We have to identify it by its nature, and after identifying that it is problem of Leibniz theorem, we try to apply that technique. Therefore, here given is y is equal to sine of m sine inverse of x. It is function of function. Therefore, differentiating it with respect to x, applying chain rule. Derivative of y is y1. Derivative of sine is cos of m sine inverse of x. And as it is function of function, applying chain rule, m constant outside. Derivative of sine inverse of x is 1 divided by root of 1 minus x square. Then cross multiplying by this term to left side, we get root of 1 minus x square into y1 is equal to m cos of m sine inverse of x. Squaring it to cancel that square root sign, squaring, we get the square of the left hand side as 1 minus x square into y1 square is equals to square of the right hand side term is m square cos square of m sine inverse of x. Then converting in terms of sine function, we rewrite that cos square theta as 1 minus sine square theta using that standard trigonometric result. Therefore, this cos square I can write as 1 minus sine square of m sine inverse of x. So this become m square 1 minus sine of m sine inverse x is nothing but y, and therefore square of it becomes y square. Then after differentiating first with respect to x, once again we differentiate this result with respect to x to get this term of y2, and therefore differentiating with respect to x, by applying product rule for left hand side differentiation. First term 1 minus x square. Derivative of y1 square is 2y1, chain rule. Derivative of y1 is y2. Plus second term, it is y1 square as it is. Differentiation of this term 1 minus x square with respect to x is minus 2x. And that is equals to m square constant term. Differentiation of this 1 minus y square with respect to x as it is function of x, its differentiation is minus 2y, chain rule. Differentiation of y is y1. Then dividing by 2y1 throughout to get the first result, to get the intermediate result, 1 minus x square into y2, dividing by 2y1, 2 get cancelled, 1 get cancelled, we get minus xy1, and this if you transfer to left side it becomes plus, 2y1 get cancelled, remaining is m square y, and that is equals to 0. We call this as a result number 1. Half part of the problem is over here. By differentiating that function twice with respect to x, we get this middle step or intermediate result. And using this result, we try to obtain the required result by differentiating these terms with respect to x n times by applying Leibnitz theorem. Differentiating result number 1 by Leibniz theorem and differentiating it n times. Leibniz theorem is like this. Nth derivative of the product uv is unv first term, second n into un minus 1 into v1, third n minus 1 by 2 factorial un minus 2 into v2, and plus so on. The last one is u into vn. Here all the suffix stand for the derivatives. Differentiation of u is in decreasing order and derivatives of v are in increasing order. And then, as already I have stated that rule, we have to consider that term as v for which we get the finite derivatives. Here the first term is 1 minus x square, whose first derivative is minus 2x, next one is minus 2, and third becomes 0. And therefore, I will consider that term as v and the remaining as u. And therefore, applying Leibniz theorem for the first term, un means nth derivative of y2, we get that term as yn plus 2. It's very simple. Add suffix n to that suffix 2 to get that nth derivative. Into v is 1 minus x square. Next one is n into un minus 1. N, decrease this suffix by 1, we get that next term as yn plus 1. Into v1, first derivative of this term is minus 2x. Next one is n minus 1 by 2 factorial. Again decrease the suffix by 1, we get that next as yn. Next derivative of minus 2x as minus 2. And as this one is constant term, its next derivative is 0, we stop here. This is the nth derivative of the first term. Then similarly, we try to apply Leibniz theorem for the second term by considering x as v and y1 as u. Therefore, nth derivative of that y1 is yn plus 1 into v is x, plus n, decreasing this suffix by 1, we get next term as yn. v1 means the derivative of x is 1. Next derivative becomes 0. Therefore, once again, we stop here. This is the nth derivative of the second term, xy1. Plus m square is constant term, we take outside. And nth derivative of y is yn. And that is equals to 0. And then after finding applying this Leibniz theorem, we try to simplify it by adding similar terms in one bracket. And therefore only one term of 1 minus x square into yn plus 2. Then 2 terms of yn plus 1. From this I can take minus x into yn plus 1 common. Remaining is here 2n, and here remains 1. Then 1, 2 and 3 terms of, therefore from these 3 terms I can take yn common. We get plus, multiplying by minus sign, we get that term as minus n square, minus minus plus n. This one is minus n and plus m square into yn is equals to 0. That is 1 minus x square into yn plus 2 minus 2n plus 1 into x yn plus 1, plus and minus and get cancelled, we get m square minus n square, m square minus n square, but required is minus. Therefore, to have that term, I will take minus n common. Therefore, when we take minus n common, this become n square, and to get plus m square, here it is minus m square into yn is equals to 0, a required third term. Okay. Hence proved. In my next video, I will present my video on the next point, that is a Maclaurin's theorem, using which we have to obtain this standard series expansion. If you like my video, please share it, as well as subscribe to my channel to receive the notification for my new videos. For that, you have to press the bell icon. Thank you.